everyone back to our channel. I'm your friend Robert. I'm here to help you get better and to tell you anything surprising, amazing, and technology. Alright, no bullshit. Let's move on to today's topic. What do we have for today? That's right, the most popular word right now, the chips. Can you imagine how crazy the chips can be? They are so smart, they are so intelligent, while they are so tiny. It has taken over our daily tasks so tremendously, and it seems to be unstoppable. No matter it's something like check the weather, why it's so warm this winter, or does the eclipse have something to do with the earthquake? Will it be the doomsday? All these questions or tasks can be done by this tiny machine. But how? What's the magic behind? Okay, so in today's video, I'm so honored to have Dr. Robert here to help answer these questions. Welcome, Dr. Robert. Thank you, Robert. I'm so happy to be here to share my passion with you. Indeed, the chips, since it first came out like about 50 years ago, it does truly an amazing job and keep evolving. You're right. So to be honest, I'm a new beginner, just like some of our audience in front of the television. So can you tell me, for the first question, can you tell me what's the first concept we should keep in mind to understand the chips? Sure. Let's start from the transistor. Why is it so fundamental? Since in the digital world, everything can be represented by a bunch of 0 and 1. For example, the transistor is like a bucket under a tap. If we turn on the tap and fill the bucket with water, it means 1. On the other hand, if we empty the bucket, it's 0. And it's the transistor that enables us to control the state of the bucket, the state of the bit. Why? But on top of that, we can now memorize, transit, and compute. So okay, now go back to the chip. Why does the size matter? Here's the bucket again. If we want to compute very fast, which means we need to switch the state of the bucket also very fast, we then will need either a strong tap to fill faster or a smaller bucket to shorten the filling time. And that's decades of people trying to do. Decrease the size of the transistor and put more transistor on a chip to do more calculation. And according to Taiwan Semiconductor Manufacturer Cooperation, which is right now the biggest cooperation to manufacture the chips, they can make the narrowest part of the transistor down to 2 nanometers. It's only about 20 atoms long. That's over 100,000 thinner than the hair breadth. Wow, what an amazing number. And thanks for your clear explanation to introduce the transistor and chips using the buckets as examples. It's really easy to understand in a way to combine the speed and filling up the bucket. Alright, now we have the transistor. How can we put all these things together onto a chip? Do we use the glue or something else? Of course not. Again, it's so tiny and complicated that we need another way to manufacture it. We make it layer by layer. What does it mean? For example, just like making a sandwich. The engineers will decide how big the base is. Let's say the bread is. Then we add toppings like semiconductors or metals on top of the base. Here with a special machine, aligner. You can think of it as a laser beam. We use it to carve the root or contact on the layer so that the current can go up or down, or a specific way to do the calculation. From the number of the Intel websites, it requires over 100 times of this process to finally obtain our chip. Remember, all the steps mentioned above are so precise in a nanometer scale. It's so difficult and energy consuming as you may imagine. Wow, now I see. What a breathtaking number, an engineering achievement. I'm so surprised that they have to do it layer by layer in order to make a chip. It's quite a genius idea. Also, your example of making a chip like making a sandwich really captures the idea. I really learned so much. Okay, it's time to wrap up. I understand how the transistor works and how the computers process the number. I know how the chips are made. I believe it's quite a huge materials for me and our new audience to understand. Again, thank you for your time, Dr. Robert. Hope to see you next time. Have a good day. I'm Robert. See you next time. Bye. You too. It's my pleasure. Goodbye.